Hello again, everybody. I'm Rob Vingerhoets. Welcome to TVL TV, and we continue on with our little series here within the Maths Essential series on differentiation. And one of the answers to catering for the range of your abilities in your classroom is using open-ended problems, and that's the sort of track that we're on at the moment. And in our last episode, we spoke about Charlie Lovett's 4 problem-solving steps, and along with those go the 10 problem-solving strategies. So let's see how far we can go into those, having a brief explanation of them, and in one of the following episodes I'll pick an activity again to highlight how they can be used in the classroom. But basically these are the 10 problem-solving strategies. There's an email address up there. If you ever need the actual poster, I can send you a poster of the strategies. Make a model. That means, as it suggests, grab some material. So this is particularly for any of those kids who are perhaps a bit more kinesthetic, so they need to touch it before they can understand the problem. It's also for kids who are visual, spatial. I can see how I've laid these out. I can see that that's an answer, and I can manipulate them. So make a model means grab MAB, grab counters, grab a meter ruler, grab something where you can touch the problem and get your head around it. So well suited to a lot of kids. Make a model. Draw a diagram, as it implies. It's a way, again, that appeals to visual, spatial kids. In the one the other day, they drew the lollipops. When we had 10 lollipops, some might be lime, some might be strawberry, that you actually draw it. It might be a problem like Uncle Jack's cookies, and Uncle Jack has 12 cookies and they're going to be shared. How many people are sharing the cookies? So you might draw 3 or 4 stick figures and start handing out, drawing little circles for cookies underneath those stick figures. So it's just a way of getting into the problem. Very popular with kids. It's draw a diagram, but the emphasis again, don't draw a picture. It's not an art competition. The word diagram is the key word there. Solve a simpler problem. Now this is a really underrated one. I didn't use it the other day, but actually the lollipops problem we could be used for 5 lollipops, something where the kids can go, oh yeah, like 2 could be strawberry, 3 could be lime, like they can actually touch one hand, they can touch their fingers, and so it's a simpler problem. So you'd be surprised how often we use that day to day. I'll use an example, like if there was a pair of shoes on sale, and they're 15% off, $120, but 15% off. Okay, how much is coming off those shoes? 120 bucks, 15% off. Now, I don't know how many of you went for 10% first and go, hold on, well, if it's 10%, it'd be like 12 bucks, so it'd be half of that again, and you're on your way. We use it all the time as adults, without even knowing we're doing it. It's solving a simpler problem. So the example of 10 lollipops, take it back to 5. I'm doing the car park activity, which is about 42 wheels, take it back to 20 wheels or 22 wheels. I'm solving, get it to $120, make it to $50, like this, and it's still the same maths that's involved. Might have been multiplicative thinking or addition or whatever. It's still the same maths, it's just a simpler problem. And a lot of times kids, having solved a simpler problem, will go back to the original one, which you can encourage, or sometimes they do it off their own initiative, which is terrific. But it still means that kid is still involved doing the same problem as all the other kids. That's essential. Love it, and it should be included. When I go through it with the kids, that's normally in my first 2 or 3 that I offer solve a simpler problem. Write an equation. Yeah, that's now we're heading into those kids who are probably a bit more mathematical, logical. So I think Charlie's things are write a number sentence. I just like going for the correct terminology straight up. It's writing an equation. I use that from prep onwards. So write an equation. Yeah, put the maths down. It's your chance to use for the kids to use the symbols that they know and the operations that they know. And make sure that equal sign is there, because the word equal is nearly in the word equation. So it's for those kids who already have their head around symbols and the job symbols do in mathematics. give them the opportunity. Sometimes in the lower grade I might get nobody using the right equation. Then I'll have a quite complex one. I've had a prep use brackets and the operations and just to solve a problem because she just saw the sense of it. Fantastic. So write an equation. Work backwards. That's so often you can start with the answer. If it was what two numbers can I multiply together to get to 24? Well, I can flip that around. Is 24 is the answer. What number can I divide it by? And what's the answer? Quotient, put it in your keywords. What's the answer to that problem? So I can flip the problem around. So I like that one because a lot of times kids go, oh man, yeah, I can do that by addition, but if I flip it over and start with the answer, like I have to buy this many items to get the $50, I can start with the $50, take off the item that I've bought. Okay, I bought the battery pack, so I'm down to $36. I bought this, so I'm down to $20. I bought this, so I'm down to $10. So it's whatever goes that way goes back the other way. It's the inverse, which you put in your keywords. So for a lot of kids, it's just the logic of that just has great appeal, has a lot of appeal. So they're the first 5 of the strategies. Might give you a bit of a little break there, so to take those on board and have a think about them. But and also work backwards appeals to those mathematical sort of logical kids. Yeah, good strategy. See you soon. We'll go over the next 5 strategies.